right, Skylar, we just had a conversation with Vincent, formerly of Rasa, now at Explosion. Explosion, right? Yeah, I keep
Yes.
confusing it with Explosion or Explosive, which is a data quality company that was started by the same people that did Spacey. So they've got a little bit of a track record. But dude, I'm blown away by Vincent. I mean, how he's able to do everything that he does is beyond me.
I agree. He's a prolific speaker, blog post author, Python package pusher across the data science space, and he's put out a lot of great work there.
So much good stuff, man. And I really appreciated it. I mean, we got right into it. We talked about how machine learning fails, why it is a problem to over optimize for certain metrics. He's got so much out there that I felt like we could have talked to him for another 2 hours and not really scrape the surface of everything that he talks about. But I really appreciate his way of looking at the whole space and some of the key takeaways for me. I mean, this idea of like trying to, I loved his fraud. He gave two fraud examples, right? But I loved the fraud example of thinking, oh, yeah, I've got this model and it was trained on some very easy fraud examples. And then I put that into production and it catches some fraud. So I'm great. I'm getting a raise. I'm the good guy. Everything's good. But then you start to question, like, well, yeah, but is there more that we could do here? So that was one, but I know you two kind of geeked out there a lot on recommender systems and stuff. What were some of your takeaways?
Yeah, so I think like broadly the takeaways that I had were, really the underlying themes here were if you're going to like apply machine learning, first start with understanding the system and the data.
Mm,
That's what's going to help you make the right kinds of assumptions that'll actually hold later. And once you have that, that helps you pick the right metric or metrics for you to focus on. And lastly, now that you can make a lot of assumptions that will hold, you can work with simpler tools, and you don't have to jump straight to the very complex all the time. And I think like a combination of this allows you to better iterate and create things that don't have unnecessary complexity. And
yeah.
we geeked out on recommender systems, like you said, because this is a place where a lot of those failures pop out because we're applying very complex techniques. And so
Yeah.
very much appreciated sort of that vein of understanding the system and keeping things as simple as you can.
So he was pretty candid when we asked him about the cliche, what is it, data-centric AI these days or
Yeah.
data-centric ML. And I loved how he referenced his now boss, I think Inez is the one that said it,
Hmm.
iterate on data, not on models. I think that is
Hmm.
so much better than data-centric AI. Data-centric AI just sounds like marketing to me. And so this iterate on data, not models, is very clear. And I loved that. I hope everybody enjoys it. We're going to jump into the conversation right now. Just as a side note, Skylar and I will both, I mean, Skylar took the lead on this, but we're going to be doing something that we have lovingly named the pancake stacks roundtable discussions, where we get together and it is not recorded at all. And we're just deep diving on certain people's choices and design decisions that they've made. So if you want to get involved in these, their monthly talks that we're having behind closed doors, get into the channel on Slack called Pancake Stacks. And without further ado, we're going to talk with Vincent. I'm going to ask the both of you, starting with Vincent, what was your best purchase since the pandemic has started?
I like to think the mic definitely. I mean, so you're doing Zoom meetings more, so like a really good mic tends to make a big difference. And other than that, I bought this the cheapest Wacom tablet where you can still see where you're drawing, and I will say that's been proven to be amazing just for writing better GitHub issues because you can add images and stuff. Those so I don't know which one of the two I would pick, but either one of those two.
What about you, Skylar?
Uh, Probably similarly, these Bose headphones. They do a pretty good job of filtering out background noise, so I can take meetings like even in noisy coffee shops.
So mine was a milk foamer, in case you didn't catch that. That was my favorite purchase. Now, let's talk shop. Vincent, I know that you've got a lot to talk about. I mean, you're a prolific man. You've got a ton of stuff on 2 websites. Actually, like, I don't know how many websites you have now, but you collaborate with all kinds of people like Spacey and PyData. You've got your really cool different websites, one of which sprung the question that I asked earlier, is This Month Rocks, what you started at the beginning of the pandemic. And it's just a place to get inspired to do different things and new things in a month and learn new skills when you're stuck inside. And I just want to let's just like get into it, man, because I know you think and you talk a lot about how machine learning can fail, and that's really what I wanted to center this conversation around. So you have some awesome blog posts, one which is a little bit heart-wrenching because I've been in your situation when you talked about having a stillborn and then continually getting ads for baby stuff after the fact, and how that is a really bad use case and how machine learning fails on us on some of that. And then you extrapolate it out on different ways that it can fail with like alcoholics. And so maybe we can just start there. Like, what drives you to get into like how machine learning can fail?
So it's a bit of an elaborate question, but like so part of me thinks like, hey, if we understand how things fail, it's also easier for us to sort of figure out how things can be fixed. So naturally, I think if you're building systems, understanding failures is just part of your job in a way. But what I've mainly noticed is that like if you go to conferences and you're looking for like what are the better tech talks, usually seeing someone on stage giving like a epic demo of something working, that's interesting. But it's usually much more interesting to sort of pay attention to someone that says, hey, this website went down for a moment, here's what happened, and here's how you can sort of prevent this from happening on your side. I've always found those stories to be just a little bit more inspiring and also just a little bit more of a take-home message, something that you can actually apply in your day-to-day. So that's typically also what I try to focus on, like on my blog. Whenever I see like a common practice it can still break, I think that's a very interesting thing to just sort of zoom into. One thing I should say in general, though, whenever I talk about these sort of somewhat critical topics, as long as you're not going on a rant, but you're just sort of trying to be honest but strict, people tend to be quite receptive. So the blog post that you mentioned earlier, that's something that the website in question in that blog post, they've actually reached out to me. Like their senior science tech lead actually came up to me and said, hey, Vincent, you're right. These are things that we'd love to sort of dive into a bit more because this is almost a poster child of stuff that could go wrong that we didn't intend to go wrong. I'm actually speaking there, I think, in a week or two with their engineers about this. So I've actually found like as long as you can sort of, don't rant, like that's the bad path. But as long as you can clearly point out that it's a failure scenario, odds are that people will listen and also just go on a fixing path. So that's kind of the vibe that I'm also going for whenever I'm doing tech talks at PyData. I try to be critical, but the intent is that we fix things. And that's also why I like failures, because if you talk about them, it becomes easier to fix stuff.
Yeah, that's super interesting, and it's warming to hear that they reached out to you and they're working to get that fixed. It's very cool that they were able to discover your blog post and find that. One thing I'd love to dig in a little bit more is I think a lot of your talks kind of center around sort of either failures but failures specifically around having complex systems. And so I'd love to just like kind of dig into sort of how you keep systems simple. I think a lot of your talks tend to have this like running theme of like, we can do things simpler. And so I'd love to just hear you unpack that a bit. Like how and why do you keep things simpler?
I mean, the simple answer is just don't introduce any complexity unless you need to. But I guess like a more overarching goal is, so a bit of a weird story, I guess, but my background is in operations research. So if you go to my college degree, it's econometrics, but the major is in operations research, which is this field of math where people sort of try to find optimizations. And if you get good grades in that, then you understand one common theme, and that is that you can optimize a system to like infinity, such that your factory is allocated such that you're most effectively using all the raw goods that come in. But the problem usually with those systems is that the price of raw goods fluctuates, and you can hyper optimize towards a given price, but if it even deviates a little bit, the lessons of operations research is then you've got a non-optimal system. So the moment that you understand that, hey, optimality is a moving target, then you got to wonder, okay, like, can I just understand the system then? Because then if I understand the system, it's easier to make assumptions that actually hold. So I like to think that I'm not necessarily going for like, oh, let's keep things super, super simple. I think I'm a little bit more in favor of let's just try to understand what we're doing. Because usually if we understand what we're doing, we can get by with a heuristic. And if nothing else, that's usually a good benchmark to start with. I think it's perfectly fine if you start with like a simple system to predict, I don't know, bad behavior in online chat or something like that. Like, let's say you're eBay and like the conversation back and forth seems to be performed by a bot. Okay, there's probably some heuristics that you can start with. And if maybe later down the line we find that a neural system works better, I think that's great. But you should probably start with a simple thing first, if only because you can test your assumptions, you can have a good baseline, and then you have something to build on. What I'm less of a fan of is that people sort of say, oh, let's try out all these algorithms that require 16 GPUs and hope that we sort of magically end up in the place where we want to be. That seems like a bit of a silly approach to me. But then again, it also depends. But I prefer to start simple because I want to understand the system. That's usually the gist of it.
Yeah, that definitely makes a lot of sense, and definitely resonates with me. One of the talks that I was thinking of when I asked sort of that opening question is you had a talk titled "Playing by the Rules-Based System," and I love that you. And actually, that's the talk that sort of led me to recommend you to come on the come on this podcast. But I'd love to just like. Maybe have you speak a little bit to that for folks who maybe haven't seen it that are watching this. So you talked a little bit about, hey, let's start with heuristics based on our understanding of the system. Maybe later we move on to kind of, something more sophisticated that works better. But I feel like you presented a very interesting sort of technique or methodology in that talk. So would you care to speak a little bit to that?
Sure. So there were two examples, if I recall correctly, in the talk. There was the one with the detecting programming languages, and there was another one concerning fraud. I'll start with the fraud one, because I think that's the funnier one. So, like, suppose you work at some financial institution, and management comes up to you and says, we need a system against fraud. Then without looking at any data, you can probably come up with a couple of just things that are pretty good to just check. So if you're younger than 16, but you earn over $1 million a year, then I don't really need an algorithm to say, well, let's check that. I mean, that's kind of fishy. If you have more than 20 bank accounts and you're like a private individual and you have 5 addresses spread over 3 countries, okay, yeah, let's check that out. We don't need an algorithm. And in fact, it might be better not to start with an algorithm here, because algorithms, they need like a person who lives in 5 different countries with 16 different addresses to be in the data set in order to be able to learn from it. So my proposal here was maybe what we need is a couple of these simple if-else statements where if this ever happens, we know for sure we can trigger the fraud, like the fraud schedule, so to say. And only when the obvious cases don't trigger, then we can resort to like a maybe machine learning type model. But the benefit is that this is a well-understood system. You can just say if this, then that. That's pretty easy to code up. It's pretty easy to maintain. And you can, if something goes wrong, like that part is relatively well understood. But the funny thing is, like, you can do these sorts of things in NLP too. Usually it's a bit different, but the other example was like if you go online, I have this spacey course that I collaborated with the Explosion people with. And the thing that I'm trying to solve there is I'm trying to detect programming languages in text. And like a heuristic that you could do there is you could say, well, Go is a really hard programming language to detect because the word Go is top 10 most frequent words in English. 99.9% of the time, not about a programming language. However, usually that word is meant as a verb. So spacey can detect parts of speech. So what you can do is you can say, hey, if I ever see the word go, but it's a noun, that's kind of a rule. Usually, spacey, part of speech detection is also a hard problem, so spacey doesn't always get it correct. But I can say, like, okay, if go is a verb, then it's not about the programming language. That's also a pretty easy rule that I can just go ahead and add. And I'm a pretty big advocate of like starting with these kinds of systems, mainly because they're nice and well understood. They're pretty easy to debug. They're also kind of easy to explain to like upper management usually, because you don't have to be a tech wizard or like you don't have to appreciate machine learning so much. So that talk was really about advocating this line of work. I made a package called Human Learn that's making it easy for you to sort of build these rule-based systems for scikit-learn so that you can use grid search and all that. And recently I've been adding some more features to that library, such that you can use like visual UI elements to sort of do more machine learning stuff with. And the next version will also have more support for like what I would like to call like looking at machine learning more as a UI problem. Because part of me thinks like if you understand the patterns in your data quite well, maybe you don't need the machine learning algorithm. Maybe you just need to figure out better ways to find good heuristics.
Wait, can we double click on that real fast?
Sorry?
Can we double click on that real fast? Like machine learning as a UI problem?
So I might not know what the slang, but what does it mean to double click on something? As in you want to zoom in on like what I mean by that?
Yeah.
Zoom in. Yeah, zoom in. Don't worry about it.
Sure. Actually, so there is a demo if you're interested. So there's a demo on the website. You've probably seen like the iris data set where there's like a red blob and a green blob and like, I don't know, like a blue blob somewhere. And it's a great machine learning demo. What you can also just do is draw a circle around it, and just everything that falls within the circle you call blue class. So that's a thing that Human Learn currently allows you to do. But there's also some tricks you can do with parallel coordinates charts. That's a really hard thing to explain on the podcast, though. Like, it's a really interactive visualization with lots of widgets. On Calm Code, I have a really cool demo with it. But for a podcast, I'm afraid I'm going to have to sort of maybe refer you to a video, because that one's really hard to explain without like a visual aid.
Yeah, no worries. We'll put a link to that in the description for anybody that wants to go and have fun and play around with it. But the general theme is just, instead of trying to code something, you're interacting with the data in a way that you wouldn't necessarily interact with it when you're writing different lines of code. Is that what it is?
It's a little bit more like, hey, what are just some common patterns in my data? And if I understand that heuristic, maybe I can just figure out a rule. So, and the fraud might be a nice example. So for example, hey, you know, most people that have like a median income and one bank account are probably fine. Okay, so yes, I can look at the data, but like I can do a couple of SQL queries. I can figure out that's like 50% of my data maybe. Okay, so that's also a way of approaching like your first machine learning model that I've just noticed in practice is very interesting. But like another way of looking at it, and that's also kind of related to the data quality, but the trick that I like to think has been moving my career forward, maybe it helps to consider two models. And just as a thought experiment, right? Let's say we have one model that is the very complex model. So like the gradient boosted tree, deep learning, what's who's it, hyperparameter, that thing. And then we have another model, which we'll just consider to be the relatively simple model. So, you know, maybe logistic regression or like something with heuristics that I just mentioned, something with very much domain knowledge. And in the case of Spacey with the Go example, right? Like I have this rule-based system that can detect the Go programming language. And I also have like a deep learning system that's learning from labels, let's say. Now, what's very interesting to do is to train those two models and to see where they disagree. Like just look at the examples where both models they're reasonably good. That both models have like a way of working and they arguably are not bad. But if two models that are good disagree, something interesting is happening. And sometimes it's because you find some bad labels, which are good to fix. But it's also sometimes that the deep learning model has figured out something that my rule-based system hasn't. And in the case of Go, I've noticed, sometimes people write version numbers as well. In like Stack Overflow questions, like Go and then like a number to indicate that it's Go version 7 or something. So sometimes you can also look at the data and sort of say, oh, wait, there's another heuristic that I can add to my rule-based system. By that time, you'll have better labels, you'll have better rules, and by golly, you'll have version 2 of your deep learning system and version 2 of your heuristics. And from there, you can once again see where they disagree. And this is a thing you can kind of just keep looping and keep iterating on. And I've just noticed this is way better than grid search, just in terms of like getting a proper model that actually can do something meaningful in a business. Like these kinds of approaches where it's a little bit more iterating on data and sort of trying to figure out what patterns in it. I honestly think that there's a good chunk of future in data science if you work more along those kinds of methods.
One of the interesting things you just briefly touched on, you said when these two models disagree, it could be because there's maybe like bad labels and whatnot. And, I think like in my experience, that is a very common problem. And even detecting bad labels can be sort of difficult. And I think especially a lot of new data scientists maybe they kind of take their labels as face value, and just assume that these are correct. So, would love to just hear more about your experience of like detecting bad labels. And I know you have another package too to do this.
Yeah, that was package number 16, I think. Yeah. but yeah, and
and there
also
was
like
that great talk where you were saying how people don't get to label, like the data scientists don't actually get to label, they have to have it outsourced because
yeah, so
data science
that was a funny
doing label is too expensive, right?
Well, that was a funny story. So like so there's a talk I did at PyData Eindhoven called "Optimal on Paper, Broken in Reality," and like one of the main gists of the talk is like, "Hey, bad labels are everywhere. This is a problem, folks." So like that was like the main thing I wanted to drive at. But I wanted to practice that talk, so I went to a consultancy company in the Netherlands. They were more than happy to have me for like my trial talk. And afterwards, you start talking to some of the consultants, folks who do data. I met this one person who was doing computer vision for like infrastructure, preventive maintenance kind of stuff. And, decent application. Sounds good. But he was complaining to me like, "Hey, everything you said is true, but I'm not allowed to sort of look at the labels because boss man thinks I'm too expensive for that." Which kind of shocked me. But like, I've met a couple of like senior professionals who get like consultancy rates who can give good models because they're not allowed to. It's a bit strange. But yeah, it's also that I've seen this website at some point. You might have seen it as well, labelerrors.com. Have you seen that?
No.
So, okay, just for fun, go to www.labelerrors.com. Basically, there's these very famous benchmarking datasets from academia: SciFar, MNIST, QuickDraw, the Amazon sentiment corpus, etc. And there's a research project that has tried to research how many label errors there are in those datasets. They have a sound mathematical trick that allows you to sort of say something sensible about that. And with that, as well as some volunteers on Mechanical Turk, well, not volunteers, I suppose they paid them. But they found out that QuickDraw has like a 10% label error. Amazon Sentiment has like a 2% label error. So if you have like state-of-the-art performance, you might be overfitting on bad labels, was like one of the conclusions of that paper. But labelerrors.com is a website you can go to right now. It's a pretty cool website, just because you can also see just how ridiculous some of these label errors are. I think you see like a plumber, and supposedly that's a hot tub according to the label. I mean, there's some really crazy ones in there. But then, of course, you look at such a website and you want to start wondering, like, gee, is this happening to my data as well? And the benefit of working in NLP is that you can usually, as a, like, not necessarily domain expert, but kind of as a layman, you can just sort of look at text and say, hey, yeah, is that positive or sentiment? It's a lot harder to do with a CSV file, but then I started running my own experiments. Just grabbed the first paper I found from Google that had like emotions data in it, and it was just too easy to find bad labels. I was actually kind of shocked and surprised. I ended up making a package just because I thought it should not be this easy to find bad labels, but apparently just a few tricks does it. I have some examples if folks are interested, but I was genuinely shocked how easy it is to find bad labels in public data sets.
A lot of the examples that you gave just now seemed like cases where it's like most reasonable people would look at it and say like, yeah, that's obviously bad. Demetrius mentioned that I work sort of in mental health, and one of the challenges there is there's like low inter-rater reliability, meaning you have two people like label the same thing, and they're going to say different things. So do you see cases like that popping up too? Do these methods detect that kind of situation?
Yes and no. I mean, I also want to acknowledge that labeling isn't necessarily easy, right? And especially if you consider, let's find people with a low hourly wage on the other side of the world who have a completely different culture than us, and let's see if they can label sentiment data sets for us and see what happens. I mean, that's what happened in a bunch of these situations, right? And like detecting emotion or sentiment, that's like a super cultural phenomenon. Like, you should not expect people across the world to sort of interpret words the same way. That's also not how language works, by the way. So it's, in that sense, it's also not that surprising that you're going to have some label errors. And also in medicine, I imagine, to like, there's a reason why you get a second opinion sometimes. And even for like, I mean, in your case, I'm assuming you're dealing with mental health a little bit. So then you're probably using like text that comes in. So like, that can be hard to parse. But even medical images, if you go to a doctor who's specialized in like, I don't know, MS or something like that, and you go to another doctor who's specialized in cancer, you give them both the same photo of a person's head, the MS person is going to say, I see MS, and the cancer person is going to say, I see cancer, because that's their specialization. To some extent, that's just human nature, but it is still a problem if you're going to train machine learning models on it. But I don't want to suggest that labeling is inherently easy. It's actually quite tricky.
So there was something that we talked about right before we hit record, and you were giving another fraud use case. And maybe we can jump into that again, because I wanted to ask you a question, but I said, wait until we're actually recording to ask you this question.
Yeah, so this is a bit of a fable, this one, but I do think it has a lot of value. So as the story goes, you are in a financial company and you're interested in analyzing fraud. And let's say that you're doing this on transactions, let's say. Then there's a bunch of interesting challenges because the data set is imbalanced. Fraud cases, those are probably well labeled, but let's say the non-fraud cases, might be some fraud in there. It just hasn't been labeled that way yet, right? So this class imbalance from multiple angles. But let's say, despite all of that, we end up training a model, performs quite well. Like, we get metrics we like, we convince upper management it needs to go into production, engineers like it, it's in production, and lo and behold, after 2 months, we actually catch 2 crooks. And let's say another month passes, we catch another crook, so everyone's getting promoted because we apparently solved the problem. Unfortunately, in this situation where everything seems to go right, tons of stuff can still go wrong. The main thing that goes wrong in these kinds of scenarios is that typically the labels that you have, you should always remember, those are probably the easy ones. Like the fraud cases that pop up in your labeled set is probably the fraud case that were easy to detect in the first place. And by focusing in on the easy cases, you might get a blind eye for the much harder cases. But then you have a system in production that's it's doing super well, so no one's going to complain, right? And so this is also yet another reason why labeling is just super hard, because there's bias coming at you from all sorts of directions, and it's very much a human problem, and we humans are not perfect. But yeah, there's tons of these stories around in industry, tons of them.
Well, yeah, we talked about how basically it's like, yeah, there may be a lot of fraud happening, we just have no idea, and it's like if a tree falls in the woods, does it make a sound? And my really big question for you is, how do you not go insane just trying to look for more and more and more? Like, you can always think, and that you're probably rightly doing so, there's probably someone that is getting past you, but when is like good enough?
So I have some friends who are like in the infosec world, and some of the practice that I hear of is that they say something like, well, this month we are concerned with like this attack surface. So we're just going to do a sprint sort of making sure that it's not our SSH keys, let's say. Okay, but the next month they say, well, it might also be social engineering. Okay, so now we're going to poke around the social engineering department. And sure, you're always looking for all the things at the same time, but you can apply a similar thing here where you sort of say, well, there's different types of fraud that happen. There's identity fraud, and I'm pretty sure there's the stolen credit card, and there's a couple of these things. And I can imagine you just try to round robin all of these like separate things that from the domain knowledge that you have are worth investigating. I think that's a sensible way of going about it. Not necessarily perfect, but at least it sounds sensible. So that's the best thing I can kind of come up with on the spot on that one. But it's hard. Like, I'm not going to, it's hard. Yeah.
Kind of backtracking a little bit, when I mentioned the sort of package that you released to find bad labels, you mentioned that was package number 16. And, that kind of blows my mind a little bit as someone who hasn't released a package at all. So just want to dig into, first of all, how do you like produce so many packages? Do you have a system that helps you do that? Like, how does that go?
I mean, so, okay, I need to take a little bit of a step back there. So not every package that I make is on PyPy, and like not all of them are meant to be used by everyone. But I will say, I mean, I have made a package where basically there's just one or two functions in them. And maintaining one or two functions is relatively easy. So like that's trick one. And then usually what I try to do is I try to scratch my own itch. And if other people like it, that's fine. But I'm only interested in scratching my own itch. So if too many feature requests come in, I politely just say no, or I ask them to fork it. And now the other trick that I tend to use a lot is I usually make stuff that's scikit-learn compatible. And the really cool thing about scikit-learn is they have a testing client that you can go ahead and use. So it's fairly easy for you to reuse their testing tools. And if you use their testing tools, you're good, because you know your stuff is scikit-learn compatible. So in that sense, if you make packages kind of in this little ecosystem this way, maintaining them is relatively easy. But I do try to make it a point to make some of these packages just a little bit more minimal, that they don't do all the stuff. They usually provide like one or two tricks. And the DoubtLab package, for example, it basically just wraps around scikit-learn stuff. So the way I try to find bad labels is I just try to predict the classes, predict the probabilities estimates that come out, and I just try to figure out, hey, when is the classifier? When does it have a very low confidence? And that's basically one line of code, really. And yes, DoubtLab has a couple of tricks, but it has a couple of these one-liner tricks. So if you build packages this way, it is relatively easy. That's the main advice I have for people who want to maybe do open source stuff.
Yeah, that's super cool to hear. So like considering you released a lot of packages, even if they're very minimal, is there one that stands out to you as sort of like your favorite at the moment?
Definitely Human Learn, sort of with the UI stuff that I have in mind. That's got a special place. I like the idea behind DoubtLab because, I announced it this morning. I'm joining Explosion, so data quality is going to be more of my day-to-day soon. So I'm very much interested in sort of exploring what tricks we can add there. I will, like, if I'm honest though, like the package that I really started with, together with a former colleague, is called Scikit Lego. That's just a couple of these weird little Lego bricks that you sometimes need in a scikit-learn pipeline. But what's really cool about that one is most of the ideas don't even come from me anymore. There's a little community around like, hey, I've got this weird little component, but there's like this moment where it's super useful. Can I please plug that in? And there's this one component this person made a while ago. I forget the name, but basically it does like his inflated zero regression. So what it does, like a lot of these regression tasks, they often have the number 0 that comes out. So if the shop is closed on in the weekend, let's say, the sales are 0. But that messes up most regression algorithms. If you're trying to predict the sales, having days where it's exactly 0 it just messes things up. So what this component allows you to do is it allows you to either add a rule or a classifier, and if that's triggered, it's always the regressor says it's 0, and if not, then it goes to the normal regressor. So it's like tricks like that, and Scikit Lego is like a little collection of like some of these tricks that are a little bit weird, but if you're from industry, actually they make a lot of sense. There's also some fairness type algorithm tricks in there as well that are pretty interesting. Some good outlier tricks as well. So that's I would argue that's the most fun to maintain.
Awesome. Yeah. I've played with that package a little bit. There's a lot of good tidbits in it. So folks listening, if you haven't checked it out, we'll leave a link to that in the description. One of the things you briefly touched on was you announced that you're joining Explosion AI. Wanted to just dive into that and sort of why Explosion? What are you going to do there? Why are you excited to join?
So it helps to kind of explain how I met them. Mm-hmm. A couple of years ago, there was a Spacey in Real Life conference. And I kind of figured, hey, I've never done NLP before. This sounds interesting. Spacey's got a cool website. Better check it out. And as an excuse to go to Berlin, and Berlin's a fun town, so go to Berlin. And I met Matt and Ines there. And I met them before at conferences, but I was hanging out with them for a bit. And like, this is my version of the story. Like, they will tell it differently. But basically what happened after a bit, like I was there during the hackathon and all that. We went to a bar with a large group. That bar was super full, so we went to another bar. And then I walked up to Ines and I said, hey, this bar's way more spacey. It's better. Like the worst joke ever, basically. But I like to think somehow that joke stuck. And later that evening, Matt and Ines kind of came up to me and said, hey, Vincent, you're kind of a funny guy. We think you would YouTube well. And we're looking for someone to sort of make some tutorials around spacey. And they were very much interested in someone just showing like from A to Z, not how does spacey work, but how would you use spacey to solve a problem. and did a couple of calls with them. And I basically said, I know nothing about NLP. I don't mind trying this whole YouTube thing out. But the deal is I got to be able to ask you questions because I want to learn this NLP stuff. And if I can learn it from you by doing this, that's a deal. Because suddenly I have like the two maintainers of like one of the packages for NLP that can teach me stuff. So I was like, sounds great. And that's how I met them. And in my free time, once in a while, I would have progress on like the program detection, like programming language detector that I was making with Spacey. And I've interacted with them like on and off for 2 years. Whenever I had time and I felt like it, I would make another episode. I think there's like 5 or 6 now on YouTube on their channel. And at some point, I was investigating all this bad data stuff, and I kind of figured, this is a bigger issue than I anticipated. Like bad labels are a huge problem. And we need a better tool for this. And then I got reminded, of course, that the folks over at Explosion made this great tool called Prodigy. So then I kind of just walked up to them and I said, hey, I might be ready for a switch. I think it might be interesting sort of if I do more demos on Prodigy. Here's just some ideas. Does this sound cool? And that was the shortest job interview I've ever had. But that's it. That's that's basically how I went. I've always been impressed with what the Explosion team has done. I know Matt and Ines a little bit informally because, we conferences and bars and all that. But this is the story, basically.
Well, and you told me beforehand that you were stoked also because it's Python all the way down. Can you explain that a little bit more?
Yeah, so I should admit, I'm joining Explosion right now, and I still have to. My first day hasn't started yet, so as far as a pitch goes, I might be a little bit unprepared. But I will say, one part about this Prodigy product that they made that I do think deserves more attention. It is scriptable. So in the end, the thing that can generate so you're going to label, and the order in which the labels appear is something that you can code yourself with Python. So if you want to do some stuff with active learning, nothing is stopping you from hooking into your favorite machine learning algorithm, your favorite backend, or your unicorn DB to sort of provide you these labels in the order that you like. You don't have to ask anyone's permission. And that's pretty epic because that means that I am free to do whatever weird human learn trick that I have at my disposal. And also I've noticed the way you want to find bad labels, usually there's a custom thing in there. There's usually a trick you want to just be able to plug in. And that doesn't necessarily happen with a UI. You kind of want to code that. And to me, that's always been my favorite feature of Prodigy. Besides, good UI components, nice developer experience, but just the fact that I can code that, that's been proven to be a boon.
That's awesome. So, I think we've covered a lot of things about, packages you've written, bad data, bad labels. I just wanted to get your quick thoughts on, as we've been talking about bad data, bad labels, the theme running in my head has been sort of this shift, so to speak, from model-centric to data-centric AI. I want to know if you have any thoughts on that, whether you think your work is complementary to that, whether you think that this is maybe hype that's unnecessary, or whether you have any insights at all on it.
Yeah, so I remember seeing a talk from Ines, she's one of the co-founders of Explosion, and I remember her coming up with the term iterating not on models, but iterating on data. That's kind of been the first time I heard about this way of thinking. So that's, I guess, the industry term for me has always been iterate on data instead of models, but I suppose nowadays there are people who call it data-centric versus model-centric. It sounds cool to me, assuming it's not a marketing term. That's always the thing I'm a little bit afraid of. But I do in general sympathize with the whole idea of, hey, let's move a little bit more towards the data. Maybe that's where the real problem is. And also these ideas of hey, if we can, if our data quality is twice as good, maybe a linear model will be fine. I think those kinds of sounds seem good. But you always got to be a little bit careful with industry terms because sometimes data-centric AI might mean a lot of stuff that I'm not aware of. That's also kind of the thing. I believe Andrew Un had a challenge around it a while ago. That was my impression, I think. I didn't participate in it. But I do think the move to sort of, hey, let's not worry too much about the tensors that are flowing, maybe worry a bit more about the stuff that's in our database. I mean, yeah, that sounds fine. But I'm not the kind of person who would use marketing terms too much, I suppose. That's my only complaint.
And so for you, it would be more interesting just to talk about the problem and not try and slap a little cliche whatever on Is that what it is?
Yeah, and also like I think that's maybe it. So like maybe a good example is I've worked with recommenders in the past. Like I've implemented a few. One for the Dutch BBC. I was at like the Dutch eBay for a bit, and I was doing recommender work there. And one thing you notice is that the recommender at the BBC is like completely different from the recommender at the Dutch eBay. For the simple reason that if you buy something off of eBay, like someone's secondhand bike, the moment you buy it, it's gone, and you cannot recommend it to anyone anymore. So the way you implement a recommender is like fundamentally different every place you go. And usually like you can read a book on recommenders, but that's not necessarily going to help you find the best solution for the problem. Usually understanding the business and maybe, diving into data quality is a better idea. Yeah.
Okay, so we've talked a lot about how machine learning fails, and I love to ask people who come on here if they have any war stories. Do you have anything? I gotta imagine you got a ton, man. So
I'm writing
give
a
us
book,
your best
so
war
yeah.
story.
So I am contemplating writing a book at this phase, but I have a few war stories. I guess the main one that I like to talk about the most is just grid search in general, and like the auto NLP. But the way I like to talk about that is just a little bit more of a thought experiment that I think is interesting. So, Skylar, I'm just going to do a little bit of a thought experiment with you, if you don't mind. Let's suppose that we both have some dice, right? Like you've got a dice with 100 sides, like mega Dungeons and Dragons dice, right? I got one of them. And then we're going to both roll, and the person who has the highest number wins. If we both roll one of these dice, so far so good. We both have an equal chance of winning. But let's now say that I say, but I'm going to roll 2 dice instead of 1. I'm going to pick the highest number. Then you're going to say, well, Vincent, that's a bit cheating. And I would say, well, but what if I do like 1,000 of them? Would that be cheating? And then you would rightly say, like, Vincent, that's totally cheating because you're using more dice, right? Like that would be cheating. So now let's say we're doing grid search instead. You're allowed to train one model, and I'm allowed to train 1,000 different models with 1,000 different hyperparameters. Like different seeds, let's say, just sort of keep it in the ridiculous realm. Just because I'm running 1,000 hyperparameters, and if there's something stochastic in my algorithm, I will always win just because I'm trying out more parameters. But I also feel like if you brag about how good your model is because you've done auto NLP on like millions upon millions of grids, then you're measuring the wrong thing. And in that sense, I don't think grid search is going to be awesome. And I have heard lots of like stories where grid search has gone wrong, basically because someone had been like pumping hyperparameters into the thing, hoping it would become better.
Yeah, it certainly resonates. I remember my days at LinkedIn watching people spend a lot of their time playing with hyperparameters and filling out very complete spreadsheets with their results. And I always seem to come across this challenge because I worked on recommendation at LinkedIn as well. Mm-hmm. People would essentially have great offline results, and then we put it in production. Doesn't work so well.
Doesn't correlate.
Yeah. Yeah. So that definitely resonates.
The thing is, and I suppose like people say you have this dimensionality reduction you can do as a trick in a pipeline, right? But if we talk about the biggest hyperparameter, like the biggest reduction you can ever do in dimensionality is to say, well, we've got this recommender problem, but we're going to boil all of that down to like one single metric. And that's the thing we're going to optimize for. Because in the end, I think that's also where a large part of the problem is. It's like algorithms usually favor optimizing a single number. And if you're interested in optimizing a system, your concerns usually vary well beyond that. But yeah, especially if you're at LinkedIn, I can imagine just because of the sheer volume, like it's hard to keep track of everything. So I can definitely imagine the appeal of resorting just to a single number. But yeah, like it's hard. That's for sure.
Yeah, and I think I don't know if you've seen this blog post. There's a blog post from someone from DeepMind, I think, where they talk about one of the problems with hyperparameter tuning, specifically like in deep learning, is that we often have multiple terms, and people think that this alpha that you have kind of like is a knob that kind of like goes between those two and how strongly you want. And like in practice, it's not how it works, and they kind of dig into how you need to like really understand like multi-objective optimization and how we're like really not getting anything on the Pareto front. And so we're getting suboptimal solutions all over the place. And it's, it's clear that there's a lot more work we need to do on like how we have a robust methodology for working with hyperparameters. It's definitely missing.
So I'm curious what you think of this one then. Is your background? If I were to say linear programming, does that ring a bell?
Yeah.
Like you have constraints as well in a system.
Yep.
So when you do operations research, this is all you do. Like you're constantly worried about constraints in your system. And part of me is wondering, well, wouldn't it be great if in machine learning we were just able to add more constraints? So if you're Netflix, for example, I would love to add a constraint that says no romantic comedies for Vincent. Just even if I never watch one, Netflix, here's just a constraint, a user telling you, I want this to be customized to me. Because that should be more valuable to Netflix than a click, right?
Yeah. Yeah.
Like it would be nice. Like, and I think that's also a very interesting sort of way of thinking about models. Like maybe we can change the data not to be a loss function, but also to be a constraint.
Yeah.
That sounds very interesting. It's numerically quite hard, but like from a design perspective, that seems like a very interesting thing to explore, right?
I haven't looked into this too closely, but I believe the TensorFlow lattice package was intended to do this. There's always a question of like, hey, the constraints we want to impose, like those are often like high level. Like the example you just gave is kind of like a high level thing. Can you actually distill that down into the math is an open question. So I'm not sure like in practice how well this package works, but definitely been meaning to take a closer look at it because definitely that resonates with like putting constraints in, and especially coming back to a lot of what you spoke to on like applying heuristics. There's a lot of places where like for a certain segment, we have a really strong heuristic and it's like, why do you even need to use a model for that? So very broadly.
So TensorFlow, I've actually played with TensorFlow lattice for a bit. It's pretty cool. The main constraint that it allows you to add is monotonicity. So you can say stuff like, if you smoke more, that's always bad for your health. And if you're into like some causal stuff, you can actually grab with that. I do know some folks in fraud industry like using that because they can sort of say, well, this is always a risk factor no matter what. And especially if you go to projects like Fair Learn is an interesting example. But in fairness, algorithm land, so to say, constraints are often also being used because they want to say, well, we want the true positive rate between these two subgroups never to differ more than a certain number, so to say. So constraints definitely make an entrance in that field. But there you can also wonder, like, what definition of fairness can you put in a constraint that way? It's also not going to be perfect, but I do believe it's an interesting area of research. That's for sure.
Absolutely. Well, great. I think we covered a lot of ground here. Really
cool.
Thank you for all of your time, all of your insights. I had a lot of fun. Hopefully you did too.
I loved it.
And we'll all be looking out for what you do in your new role at Explosion. Very excited to see what new things come out from you and other folks there. But I think with that, we can wrap this up.